are safe and fine and taking prevention for this coronavirus. I myself am Sunil Kumar, starting the next online class for you. Before that, I am also staying home and taking prevention for this coronavirus. So now you see the next, today's online class for all of you is the chapter number 10, that is called as mensuration. Chapter number 10, that is called as mensuration. This chapter is a very, very important chapter. Most of the questions in the exam will come from this chapter. As it is already over in 9th class, I am just going to give you the introduction of this chapter in this video today. So let's start it. So when I am starting the chapter number 10, this is my chapter number 10. Chapter number 10. This is chapter number 10 called as mensuration. So now you see, I gave you some introduction here. What is the introduction? My introduction is divided into 4 parts. First part, second part, third part and fourth part. According to these parts, our study, our classes will go on. The first part is carrying surface area and volume of different solid shapes. Surface area and volume. Area and volume. Very clearly you know about the area and volume. Area and volume I will discuss with you later. And what are the solid objects? The objects which occupy space and having mass is called as solid objects. Solid objects, they are having area and volume. This total figure is under exercise 10.1. Try to remember, it is under exercise 10.1. Exercise 10.1 is dealing with surface area and volume of different solid shapes. Clear? Now come to the second phase. Second phase is surface area of combination of solids. When you are combining two solid shapes, that means a cone is combined with a sphere, a cylinder is combined with a cone. So on that is the combination of solid shapes is in exercise number 10.2. So I divided my lesson into 4 parts. According to that, I will try to understand you. I try to explain you, by which for your better understanding. Then you go for exercise 10.3. What is 10.3 all about? It is only for the volume of combination of solids. When the solids are combined, how to calculate their volumes. It is on exercise 10.3. And the last part of the exercise is having the conversion of solid form. One form converted to another form. So conversion of solid form, one shape to another shape. One shape to another shape when it is converted. Then how to calculate their volumes or areas. Now come to this part today. What is the part all about? It is surface area and volume of different solid shapes. Before that, I want to say you something. What do you mean by a solid? A solid is an object which is occupying space and having mass. If anybody is occupying space, definitely it is occupying space means it is having some area inside it. So for this explanation, I must go to the next page. Try to understand the next page very clearly, and the heading will be the surface area and volume of different solid shapes. We are dealing with exercise 10.1. So let's go for it. Surface area and volume of different solid shapes. I am just rubbing it because my explanation point is today this one. So later we will go for these things. So now you see what I am doing. Now you see what is coming, surface area and volume of different solid shapes. I have in our earlier classes, we already learned about the surface area, volume. What is an area? See now, if I am taking a solid object in a rectangular form. So this is the length of the rectangle, this is the breadth of the rectangle. So now what is called area? Area means the space inside it. The space inside is called as the area. Okay, and it is called as a two-dimensional figure. First of all, you try to understand what is a 2D figure, and then go for the 3D figure. Today I will say about in my explanation. So first of all, you see 2D figure. What is D? D means dimension. this figure is on 2 dimension only. That is, when I am going for a graph paper, I am going for a horizontal axis and I am going for a vertical axis. That means it is called as x-axis and this is called as your y-axis. So if like two things are there, two axes are there, and the figure is belonging to x-axis and y-axis, then they are called as the 2D figure or two-dimensional figure. Two-dimensional figure. They are called as two-dimensional figure. I hope you understood it. It is called as two-dimensional figure. But when you see, I am taking this on plane, another imaginary axis is rising from it. So the x-axis is here and y-axis is here, and an imaginary axis that is called z-axis is here. Imaginary axis, that is called as a 3D figure. That is called as a three-dimensional figure. That is a three-dimensional figure. Three-dimensional figure. You will ask me, so three-dimensional figure. You will ask me, sir, why you are telling this two-dimensional figure and three-dimensional figure? So today my point of explanation is which figures, which geometrical figures are giving you the 2D shapes and which are giving you the 3D shapes. That one I want to explain you, and what they are giving us on formula basis, what they are giving us. See now, I am taking a rectangle here. It is a two-dimensional figure and the dimensions are length and breadth. But when this rectangle, I am going to just enlarge this rectangle with a 3D. Then I am showing you the 3D. Now this rectangle is what it became, you see. It became a 3D shape now. So a 2D shape became a 3D shape. That means here you are saying it is a length is here. And you are saying this one has breadth, so breadth is here. So now you see what is coming inside. This is the imaginary axis, that is called as the height of the rectangle. That means in 3D figure we are getting 3 dimensions, length, breadth and height. But in 2D figure we are getting 2 dimensions only. I hope it is clear to you. Now you see in this 2D figure, he is asking you surface area and volume. These 2D figures, 2-dimensional figures, always giving you area, perimeter. These are always giving you area, perimeter and perimeter. This is always giving you area and perimeter because it is belonging to 2D figure. I hope you understood this 3D, 3-dimensional. So now you see here we can calculate the area and volume. We can calculate area and volume. So one thing attached here, that is called volume. Here we are going to calculate the perimeter and area. Here we are going to calculate the volume also. So area is there and volume, one extra added. So in 3D figure we are going to calculate the volume and area, and in 2D figure we are going to calculate the perimeter and area. So when a perimeter and area is asked to you, definitely the figure belongs to a 2D figure. That means a 2-dimensional figure. I hope you understood the difference between the 2D figure and 3D figure. So 2D figure always having 2 dimensions in it, that is length and breadth. Now you take this, what is this figure? This figure always, it is very familiar figure, that is a square. This is a rectangle. You are saying this is at a rectangle. So I need not say you these things, but again I am revising it. So now you see this is a square. So this square, when you are in your earlier classes, what you are doing, the square having see, here it is the x-axis, here it is the y-axis, having 90 degree here. Okay, so now we are having 1 dimension and 2 dimension. All sides are equal. For that reason, here 2 dimensions are there. So it will give you a perimeter and area. It will give you a perimeter and area. It cannot give you a volume. Try to understand. It cannot give you volume. All 2D figures, they cannot give you volume. Only they will give you area and perimeter. But whenever we are going to enlarge this square and we are producing in a 3D shape, then what will happen? See now, what is happening? Now it is the square. Again you introduce another square in it. Then what it is giving to you? See now, it is giving to you what? This is the original square, side. This is the side, side, side and side. So now it alerts. What is the new thing you saw here? This is the new thing. This is also the side is equal to the side. Clear? But this is the another dimension came in this figure. That is producing this figure to a three-dimensional figure. So here we can calculate as a volume. In our daily life, it will give you area and volume as well. In our daily life, we are going to observe many things like this. Look at it. What your board is? Your board is a rectangle now. Okay, but if I will calculate the thickness of the board here, the thickness of the board is here. If I will calculate it, then it is a 3D figure. My duster, you see, my duster, it is a 3D figure. Why? Because my length is here, my breadth is here. This is my breadth and this is my length. But one thing attached here, that is here called as height. So it is in 3 dimensions. So definitely it is a 3D figure. So I am not going to name them. In my later classes, I will explain about those names and the enlargements. Now you just understand about the 2D figure and 3D figure. 2D figures are always giving you area, the space inside it, and the volume in the 3D figure. Volume also the space occupied. How much space is inside this? This is a room now where I am doing my online class. It is a room now. Inside the room, it is having 3 dimension it has. So definitely in my room I have giving me some volume also, because the inside the space occupied by this room is called as the volume of the room. Okay, now you understand. I hope you understand it. A 2D figure and a 3D figure. Let's come to some. Today I want to say you some synopsis. This can be noted in the CW also. Please try to write it in your rough notes. Come with your pen, pencil and your rough notes and textbooks with you, by which it will be easy for you when I will say, you can understand it better. So our heading is today surface area and volume. Which figures are giving area? I said you 2-dimensional figures. And which figures are giving volume? I already said to you, that is called as your 3-dimensional figure. So these are available in solid shapes. All solids, the shapes of the solids are maybe 3D or maybe 2D. I hope you understood it. Now come to the point. Go for some synopsis. What are the synopsis? So this is my heading today, surface area and volume for solid shapes. Now you go for some synopsis. What are the synopsis? I am writing it and after that I will explain you. Go for this synopsis. Please note it down. Synopsis. So now you see what are the synopsis. Okay, number 1. I am writing here number 1. Very slowly I am saying to you. That is called rectangle. First of all, I am saying the synopsis as a rectangle. See now, it is a rectangle. So now what is a rectangle? A rectangle, he said, there is 2 dimensions are available. The figure of the rectangle, I am doing the figure of the rectangle for you. Now you see, there are 2 dimensions are available. One is called length, another is called breadth, and opposite sides are equal. Opposite sides are equal. This is equal to this and this is equal to this. So this is breadth, this is length. Clear? Clearly it is in 2 dimensional. Okay. So now, so we can say, I don't want to say you what is a rectangle. Everybody knows it. Opposite sides are equal and length is equal to length and breadth is equal to breadth. And what is happening? This is giving you what? This is a 2-dimensional figure. So what it will give you? It will give you a perimeter. What is the perimeter? Perimeter is the surrounding boundary of the given figure. What is the boundary? If a person is walking from here and it is coming to here in this direction and coming to here again in this direction and fulfilling and going to here also. So it is just covering the boundary. So perimeter is the surrounding of the given figure or the boundary of the so we can, in our earlier classes, what you are saying? You are saying that it is the sum of the 4 sides. Sum of the 4 sides. So what are the sum of the 4 sides? L plus B that is equal to 2L plus 2B. If 2 is common, then it is L plus B. And it will come in units. That means centimeter, meter, like that. So that is called as the perimeter of a rectangle. Then when I will say you about the area, now you see what is the area. Area is always length into breadth, and it is coming under square units. It is coming under square units. Square centimeter, square meter, like that it will come. So what happened? It is a 2D figure. It is a 2D, two-dimensional figure. So what it gave you? Perimeter and area. When this figure is, I am going to enlarge this figure to 3D. Now you see what is the 3D. Clear? 3D is, look at it. I am taking a rectangle now. And what I am doing? Introducing another rectangle inside it. Now I am joining. See now what I got. I got a enlarged figure of a rectangle. So this is our original rectangle. So this is our length from here to here. This is our breadth from here to here. And one thing extra added, that is called as height. So this is the extra enlargement, and which make this 2D figure in converting into 3D figure, three-dimensional figure. Okay, so now better example, I am showing a box to you. See now, what is it? The face is a rectangle. See very carefully, you see, watch it very carefully. You can able to understand nicely. See now, what is this? This face is a rectangle. Yes or no? Yes. So this is our length. This is our breadth. Clear? So now, so this face is a rectangle. So now just go to the next page. See what is this? This is also another rectangle. Okay? This is also another rectangle. Clear? This is also another rectangle. So definitely these faces are, what is this? This is a 2D figure. But when this one is attached, see now, this one. What is this one called? Height. This is length. This is breadth. See now, this is breadth. This is length. This is breadth. This is breadth. And what is this one? This one is called as the height. This is introduced and making this figure into a 3D figure. So first of all, like this, our rectangle is here, length, and this is the breadth. Clear? I am just doing like this. See, the length is here, the breadth is here. Clear? Now what is this? This is a height introduced. Now length, breadth and height. So 3 dimensions came. So it is called as a definitely a 3D picture. So what is this called as? This is an extension of a rectangle. This is called as a cuboid. What is this called as? This is called as a cuboid. So when a rectangle, a 2D figure enlarged to a 3D figure, this is called as a cuboid. Rectangle otherwise called as a cuboid. So let's write it. Here I can write it. The rectangle, now it is became what? Cuboid. It has become a cuboid. Due to what? Due to the height introduced. Due to the height. Okay. So here height is not there. Here height is there. So due to the introduction of this height, this 2D figure changed to a 3D figure. 3-dimensional figure. And it is called as a cuboid. A matchbox, a duster are the very good examples of these cuboids. Clear? And I took a box for you. This box is a very good example of a cuboid. See now. Clear? I am going to explain you what this figure is going to give you. This figure is going to give you area as well as the volume. Volume means the inside it, what are the space involved, how much it is occupying, the space, that is called as the volume. Inside the figure. Understood? Inside the box, how much place is there, that is called as the volume of the box. So now, what are the things involved? I am writing, then I am explaining to you nicely. See now, what I am writing. First one, I am writing for you. It is giving you 2 types of area. It is giving you 2 types of area. Try to understand, it is giving you 2 types of area. So, look, what you are observing, see, when this box is like this just in front of you, you are looking one face. This is one face. This is a rectangle. See, this is a rectangle. Then I am just moving it. You are looking another face. This is a rectangle also. So first face, this is your first face, this is your second face, this is your third face, and this is your fourth face. So when I am just revolving it laterally, I am going to watch how many faces? 4 faces. 1, 2, 3 and 4. 1, 2, 3 and 4. When I am just turning it laterally. So that is laterally. The word came laterally. So when we laterally means the side, the surrounding. In surrounding, how many faces are available? 4 faces are available. 4 faces are available. So 4 surface area will come. So that is called as lateral surface area. What is that called as? Lateral surface area. So lateral surface area always involved in 4 sides. 4 face, not sides. 4 face. This is one face. This is the second face. This is the third face. And this is the fourth face. When I will rotate, you can observe this 4 face nicely. Clear? So these 4 faces are called as the lateral surfaces. Lateral surfaces. So we have to write like this. What is first area we got? We got the LSA. That is called as lateral surface area. Lateral surface area is the formula I am directly writing. How I got it, I will say you now. 2 into H into L plus D. Okay, square units. Why square units? Because it is an area. It is an area. So area always comes within square units. Understood now? Then I am going to go for it. The another area. How it can, I will say you now. But you see how many areas are coming. So first area came in this figure is lateral surface area. Lateral surface area. This one, this one, this one and this one. So 4 sides are coming. So it is called as the lateral surface area. Now I am going to show you, see, what is the pending now? First surface, second surface, third surface and fourth surface. It is giving you LSA, lateral surface area. What is pending now? The top one is pending and the bottom one is pending. So total how much? In 6. So whole total we are getting how many? 6 surface areas. 6 surface areas. But laterally 4 surface areas. 1, 2, 3 and 4. So 4 surface areas we got it laterally and total we are getting 6 surface areas. So total, the word came total. That means total surface area is 6. So when you are calculating the total surface area, we are dealing with the 6 surface. For that reason that is called as TSA or total surface area. I hope you understood. So the next one is called as the TS and A. That is equal to 2 into LB plus BH plus LH. That is square units. Square units. So you got it. So this 3D figure is giving you 2 areas. One is lateral, another is total. Total 6 surface areas, dealing with 6 surface areas, and the lateral is always dealing with 4 surface areas. So try to remember that. So when you are asking about lateral surface area, then you are dealing with 4 surfaces. And when you are asked about total surface area, you are dealing with those 6 surface areas. Okay. So now another thing it is giving to you, that is I said you the 3D picture always give you area and volume also. So now this is the volume. What is the volume? So I am showing you the volume. See now when I am opening this box, when I am going to open this box, see now I am going to open this box. Okay, so now I opened it. Clear? So now you see what is there in the inside the box. Something is there inside the box. What is that? That space. See now, this is the space. So this space inside the box is called as the volume of the box. Okay, that how much space inside the figure, it is called as the volume of the figure. Okay, I hope you understood what is called as volume. So now you see the volume I can write for you as length into breadth into height. That much cubic units. Please write it cubic units, because volume always come in cubic units. I hope you understood this rectangle formula. Rectangle, again I am saying rectangle. It is a 2D picture having two dimensions only, length and breadth. Two-dimensional figures always give you perimeter and area. I calculate the perimeter, so sum of the four sides. The basic formula for it, that is 2 into L plus B units, because the perimeter always come in units. Now I am going to calculate the area. Area of this 2D figure is the two dimension, length into breadth. You have to multiply and write square units. But when I enlarge this 2D figure to 3D figure, what I introduced a height here. See, this is our length, this is our breadth, and a height was introduced. So L, B, H, it became in now 3 dimensional. 3-dimensional figures are always giving you area as well as volume. Here we are getting 2 areas. 2 areas means I showed you what are the 2 areas. 2 areas means I am taking the example of duster now. First surface, second surface, third surface, fourth surface. If you are moving this object, how many lateral surfaces you are going to see? Lateral means side. So how many side surfaces you are going to see? 1, 2, 3 and 4. So that is called LSA. I am giving the area 2 into H into L plus B. Now when it is a TSA, I am taking the top and the bottom into account. So it is dealing with 6 areas, surface areas, and the formula is 2 into LB plus BH plus LH, and the volume is the space inside. I showed you now the space inside. The space inside it. What is the space inside it? That is called as the volume of the figure. The space inside this figure is called as the volume. This is called as the volume. Clear? You can take your room also, no problem. A room is a very good example of a cuboid. If length is there, breadth is there, and height is there also. And inside the room, what is there? That is the volume of your room. And it is L into B into H and cubic units. I hope you understood the cuboid. So our first chapter is the cuboid. So there is the first synopsis for you, that is rectangle and cuboid. Rectangle enlargement is called as the cuboid. Rectangle, a 2D figure, and cuboid is the 3D figure. Similarly, just now I want to say you the second synopsis. The second synopsis, I hope you just write those formulas. It is available in the book also. In the state book you follow, and you can write the formulas also. Now I am going to introduce another figure for you. See now. What is that another figure? I am going to say you. See now. The another figure is called as the square. It is called as the square. Everybody familiar with this square? So for the reason I am saying second. It is the second synopsis for you. What is a square? A square having 2 dimensions where all the sides are equal. All the sides are equal and creating 90 degrees. Clear? Now if I am saying the sides is A and A, then what I said to you, square is a 2D figure. It is 2-dimensional. Right here 2D. Now what 2D figure is giving to you? The perimeter. First one you write perimeter. What is the perimeter? Sum of the 4 sides. A plus A plus A plus A. What is that coming? What is that coming? That is coming 4 into A. 4 into A. Or 4 into side. Units. You have to mention it in units. Centimeter, meter, like that. And when you are talking about a area, it is giving you area. I said you, it is the product of the side. That means A into A. What is that? A into A. What is that? It is called as A square. That means it is coming in square units always. I hope you understood this one. Next one is, see now, the square is enlarged to a 3D. A 2D will be enlarged to a 3D now. Now you see, when I am enlarging this square will be called as a cube. A cube. I hope everybody understood a cube. Many students are playing with a cube also. So that is a perfect example of a cube. A Ludo dice is also called as a cube. So what is introduced here? See now the figure. A square is there. Inside a square you put another square and join the figure. And what you are getting? Definitely you are getting a clear. Definitely you are getting a cube. Okay. In Ludos it is 1, 2, 3, 4, 5, 6. Here it is 1. Here it is 2. Here it is 3. Here it is 4. Like that. Ludo dimensions are there. Okay. So forget about these dimensions. Go for and say this figure as a 3D figure, because this is our original square, this is our side, this is our side and side. What is introduced here? Here it introduced a height, H-E-I-G-S-T, height. A height is introduced. For that reason, this figure enlarged to a 3D figure, three-dimensional figure. So I have a cube for you. See now. See, this is my what? Original square. This is my original square. Side, side, side and side. This figure. Clear? So it is a 2D figure. What is introduced here? A height is introduced. See now. Here it is the height. The height is introduced here. So this it became a what? Cube. Now I said you all the 3D pictures are giving you lateral surface area. Lateral means the surrounding. See now, this is one face. You can call face. Don't say side. This is a face. This is a surface. And another one second surface. Another one third surface. Another one fourth surface. So now when I am rotating this, I am going to see four surface. So that is called as, what I said you, that is called as LSA. What is LSA? Lateral surface area. It is dealing with 4. What is one surface area? A square, side into side. This is, so how many you are observing? 1, 2, 3 and 4. So it is 4 into a square. 4 into a square. Always in square units. Now it is very clear to understand that lateral surface area always dealing with four surfaces. 1, 2, 3 and 4. Now what is pending? The top is pending and the bottom is pending. Now I just added how many it became? It became 6 surface areas now. Then for 6 surface areas, what you are going to get? The TSA, the total surface area, dealing with 6. 1, 2, 3, 4, 5 and 6. Clear? So now it is 6 into a square. That is called as total surface area in square units. Clear? The units are very important. Please don't forget to give the units after the sum has been done. Otherwise, marks will be deducted from that also. Then, what is the third thing it gave? The 3D figure always give you the volume. That is the volume. So, what is the volume? I said you the place inside it. The place or the space inside that, inside the cover. What is the space inside the cover? Now you see, the space inside the cover is this one. Something I put for your better explanation. So how much it is inside this, that is called as the volume of this cube. Volume of this cube. I hope you understood this volume. That is equal to A into A into A, because all the sides are same. In the rectangle case it was L into B into H, but here it is side into side into side. That is equal to A cube. Cubic units, you can say it as cubic units. Clear? So the units are must be mentioned nicely. So up to this 2 synopsis I will go for a lot of synopsis now in my next video. I hope you understood about the classification, introduction classification I gave to you. 4 parts I divided your chapter. First one is surface area and volume for solid shapes. These are all solid shapes. So under the 2D and the 3D pictures or the figures, 2-dimensional and 3-dimensional figures, and what is the difference between them also I explained now, and also I gave you some synopsis about the square, rectangle and the cuboid. So when the rectangle is enlarged, it is called as a cuboid, and the square is enlarged, it is called as a cube. Square is a 2-dimensional figure and the cube is a 3-dimensional figure. I hope you understood it nicely. Thank you very much. Wait for the next video.